Okay, we'll see if this series converges absolutely or conditionally, or maybe the series just diverges. Well, if the question is asking us to check for absolute convergence, first we will check the absolute value version of that, right? So let's just go ahead and make that happen. Let me just put down we check. Well, here we have the series as n goes from 1 to infinity, and again put the absolute value right here, and we have cosine of pi n, and then divided by n squared like this. Well, the truth is when you have cosine of pi n, if n is 1, you get cosine of pi, which is -1. And when you have n is equal to 2, cosine of 2 pi is actually +1. So it's actually just -1, +1, -1, +1, so on. So it's actually alternating. But in fact, it doesn't really matter in this case. Because when we have the absolute value around cosine, or maybe for sine, we know the following. So let me just put this down right here for you guys. This is what we know, right? So this is the little note. When we have absolute value of cosine of any angle theta, we know that this right here is less than or equal to 1, because that's a range for cosine. So with that being said, we can do the following. We get to establish this inequality right away, right? Because of this. So here we go. We'll just write down the series as n goes from 1 to infinity. Well, absolute value of this is less than 1, right? And then on the bottom, n squared is always positive, so we just have 1 over n squared like this, right? Let me just write down the 1 better for you guys. So again, we established this inequality right away because of thanks to the trick, the things we learned from trick. Now, what do we know about this? Notice this right here, the n is, the p right here is 2, right? Which is greater than 1. And this is the p series, and it actually converges. And notice that we have this right here is less than or equal to that. And we have shown this already, again, thanks to this. So, what do we know about that? We know this series also converges by direct comparison test, because again, this inequality was established by this. You don't have to do the 3 steps in this case because thanks to that, right? So, as you can see, we took the absolute value of that, and this right here converges. Therefore, this right here is absolute convergent series. And that's it. You don't have to check anything else, right? Because when you have absolute convergence, it's automatically converged for the original version, right? So that's it.